Oh, I didn't see you there. Hi, I'm Mr. Mays, and I've just fabricated an introduction so that I can talk with you today about your coveted, brilliant, and wondrous midterm that is to come. Yes, a midterm is a beautiful thing, an opportunity to look at all we've accumulated this year. The area under the curve being dense, brilliant, and beautiful. And lessons therein found have been all yours, personalized, for the first half of our year in statistics. And what better way I thought to do this than to, of course, involve my son, Miles. My figuring is if I can explain to him some of the statistical concepts you'll need for your midterm exam, then I can do it for anyone. And that would mean that I've done a successful job in preparing you for your own exam. So, Miles, if you'll say hi to the crowd. He's not quite at that point of cogency, but he's ready to work with us today. So, we're going to lock and load. Miles, it's time to teach you a thing or two. All right. Hey, buddy. Hey, buddy. Okay, so here's the deal, dude. Here's what we're going to talk about today. Today we're going to learn just a little bit about the way that things work on the curve. Okay, so if you'll take a look here. I know. Okay. So the first thing, Miles, I want you to notice is sometimes we have these things called distributions, right? And one of the things that you should know when preparing for my exam is that you will have one of many different kinds of distributions that you'll be working with. I know, I'm gonna show the distributions now, okay? So you might have, right, a left skewed distribution. Miles, you're gonna get in the way. It's a left skewed distribution because, well, this is a whiteboard, Miles. It's the way. A left skewed distribution is when the tail is on the left. And then a right skewed is when the tail is on the right. Thing one to be aware of. You will often see graphs, histograms, dot plots, all of those quantitative metrics. You should know them. You should know how they work. And you should be able to look at them and do seesawks on them, right? So make sure you're comfortable with seesawks and the way you can use it to describe different quantitative distributions. As I said in class, you should also be aware of how to compare different quantitative distributions. So two box plots, for example. You should both be able to make a box plot and compare two different box plots effectively. In much the same way that my son grabs at my hands, you should be grabbing at the material between two dot plots or between two box plots and determining, well, for a box plot, things like median and interquartile range, making a comparison about how tightly packed the interquartile range is and therefore how varied or unvaried in that case the data may be. You should also note the relationship between median and mean and outliers, right? That like anytime you have an outlier, that will skew the mean in the direction of the outlier, right? Versus medians will not worry about it. Good job, Miles. Think about it. You see him, he plucked his, he did that. So if Miles is a distribution and you were to look at him, right, if his arms normally are very, set up, then if you have an outlier that's over here, Miles might try to grab it. Are you going to try and grab my hand? No, he's not. Okay, if he does, good job though, buddy. It will pull him to one side if Miles is the mean. If he's the median, of course, he's not going to be affected by it. I know, buddy. So you should be able to do that. I would go through Unit 1 and Unit 2 concepts, but specifically in Unit 1, the areas where we look at different quantitative visualizations and we determine, what are they doing and what are they effectively showing, right? And in context, mind. So good. This is how happy you'll be when you study. Go through the old video notes too. Do it. Review. And I will warn you, for the FRQs, you are absolutely going to have an FRQ, I would say, where you go and you have to run seesawks and you have to do a comparison of two different visualizations, whether it's two box plots or two histograms. Hint, hint, I like a box plot, a comparison between two box plots. And then effectively we'll have to see how, mean and median will react to different scenarios and what different values will do to that. For example, if one median is higher than another median, but then there's an outlier in the lower median's distribution, right? That if you were to compare the means, the one with the outlier is going to have the higher mean if that outlier is on the higher end. The other thing that I would highly recommend having in your repertoire is knowing how to do expected value distributions. Absolutely. We've done that a bunch of times, but as Miles will tell you, they're very, very important. So being able to take the values x and multiply them by the probability of x occurring, remembering that it's only a valid distribution if all the probabilities add up to what, Miles? That was your line. You had one job. You had to say one line. The answer is one. You had one line. You had one line. Oh my God, we're going to fail this midterm. We're not going to fail this midterm. We've got this. I found my energy. You just whacked me in the face. Are you kidding me? Thank you. He got me back into gear. We got this. Don't we got this? Tell him we got this. Just a vacant stare. A boo. Okay, in the vein of those probability distributions and those expected values multiplied by their probability of occurring, be aware that you might want to calculate the proportion that's missing, right? Again, by subtracting all the other proportions from the value given, one whole. You might, as you remember, get like a, show me the number of cumulative values that lead to at least blank amount, right? So if I have a probability distribution adding up the proportion multiplied by the expected value for each subcolumn leading up to a point, right? So if it were like a bunch of weights and the probability of a baby boy being a certain weight, and I were like, give me the proportion of child weights that are at least 50 pounds. And you would go through all of the weights below 50 pounds multiplied by their probabilities and add them up cumulatively, and that would be your answer. And remember your givens, right? The odds of blank given blank. The given will be your denominator, and you will calculate accordingly. And be aware, for a lot of these, it will feel like you're just like going through, and especially for expected value, you're doing some basic math applied sensibly. So just know that you know what you know. Does that make sense? And go back through and make sure you feel comfortable with a bunch of different kinds of questions so you don't feel stuck or unsure when you hit a question that's phrased a little differently or asks for something a little different. You know what I'm saying? Because that's okay in life. Sometimes that happens. And you go on anyway, because you're a legend and a hero. Be aware, conversions, right? Translations or transformations, those are very common too. So know how to transform the values on your expected value distribution. So if it's in dollars, turning it into yen, for example, might be something that I might do to you. So be able to make those translations effectively just by multiplying the mean. And then if you're doing standard deviation, be aware that you're gonna multiply the standard deviation. But don't add or subtract from the standard deviation. Okay. Some other things to be aware of. Important things to be aware of. Know how normal distributions and normal curves work. Know how to use mean and standard deviation to calculate norm CDF. Know when you need to do 1 minus the value under the curve versus just the value under the curve. As Miles will tell you, when looking at a normal distribution, you need to figure out what side of the normal distribution you're actually able to calculate, we're looking at, and then you might have to subtract from the area under the curve. As Miles will also tell you, Miles, we don't eat the normal distribution curve. What Miles will also tell you is that within the normal distribution curve, Miles, what did I tell you about we can't eat the normal curve every time you get hungry? We also will note with binomial curves, right? So cumulatives, binom CDF, or geometric, CDF. We're in a situation where we can only do the left tail of the test. We can never do the right tail. So those are the instances where if you want values above a certain point or odds of a thing happening above a certain point or after a certain point, you'll do 1 minus the area before the curve and use that value to effectively calculate the right tail of that curve. And as always, be comfortable with all kinds of graphs, visualizations, categorical ones, right? Like bar graphs, side by side, segmented. And then also quantitative graphs, right? Histograms, box plots. Go through those, especially the categorical ones. We haven't looked at those in a while. Be sure you can compare them. And two-way tables. Know your two-way tables. Be able to read a two-way table. Know your givens in a two-way table. Those are things I would look out for. Know, of course, how to do calculations for individual samples, right? So like the bunny example from class, there are 42 bunnies or whatever it is. Know how to run calculations if you're told the shape of the distribution, of course, which you have to be. So be able to run distribution work on samples and find them, work with the mean and standard deviation. And then, of course, know how to use sampling distributions and use the central limit theorem, use the large counts condition if we're dealing with proportions on the other hand, and just know how to apply those and feel comfortable with both samples and sampling distributions. We did a little bit of practice noting the difference between those two, but know when that difference is present. My next piece of advice for you is this. Read very carefully. Very carefully. Because if you don't read carefully, you might find that you pick the wrong answer for certain things, or you think they're asking for one thing and they're not. Or you think they're asking for something very complicated and they're asking for something very simple. Or you think they're asking for something very simple and they're asking for something very complicated. So use the question to your benefit to make sure you know exactly what they're looking for. Feel comfortable with tree diagrams. Be a tree, Miles. See, this is Miles as a tree. Do a lot of tree diagrams. Make sure you're comfortable with doing tree diagrams when probabilities are difficult. Okay. And then, of course, when you're not doing tree diagrams, know your probability of A union B rules, your independence rules, good dance, your independence rules, and your rules for intersection and things like that. So go through your old probability rules from Unit 3. Make sure you know how to apply them effectively. Yes. Know when you're being asked a question about a union equation and when you need to just do the probability of A plus probability of B minus the probability of A intersection B. Know how to translate means and standard deviations. Know how to compound means and standard deviations. We've gone over this a lot, but know how to do that. Remember to think logically, right? Like you got to make sensible choices. So when you see a problem, be able to logically work through, especially the ones with visualizations or tables, how to work through and see if that thing is useful to you. And if it is, find the easiest possible way to use it to get to an answer. Also use your answer choices to help guide you to the correct solution. And the last big thing I want to say to you is be sure that you know how to adjust a standard deviation for a sample mean, right? Into the standard deviation for a population's mean, and vice versa, right? My hand's being eaten. Eat it up, big dude. Eat it up. So an example, I'm going to give you actually, you are so lucky. I'm going to give you an example question that would be very similar to the kind of question you might get on a midterm from me. Let's say Phil is really good at eating food, okay? And he eats an average of 480 grams of food per day. I actually don't know how much that is. But let's say he makes, just on average, the total of all the days that Phil's been alive, he eats an average of 480 grams of food per day with a standard deviation of 70 grams, right? 480 and 70 grams. He wants to get an average of 600 grams over 90 days, right? So we have our total, quote, population mean and standard deviation, 480 grams on average and 70 grams of standard deviation. But then we're saying Phil does an experiment where over 90 days, he's going to try and eat an average of 600 grams a day for 90 days, where the sample size is 90. And I would say how many standard deviations above 480 is Phil's goal? Okay. So in a question like that, you might find that what you're trying to do effectively is find the sample's standard deviation. Because like I said, I want you to tell me how many standard deviations above 480 600 is. And that's not saying how many standard deviations of the population sample it is. Exactly. You tell them. That's what I'm saying. Oh, no, not that. What I want is you to tell me how many standard deviations in the sample we're dealing with. And it won't say that, but that's what's expected. And the first thing you'll do, because you're smart, is you'll do 600. I'm trying to tell them. 600 minus 480. And that will give you 120, right? So we're going to divide the standard deviation into that, see how many times over that is, right? But what we have to do in order to figure it out is solve for the standard deviation of the sample, right? So we will take the true standard deviation of 70, and we will divide by the square root of n. N is sample size, I said to you, was 90 days, so square root of 90. And so you'll do a calculation similar to this, wherein you are doing your 70 standard deviation for the total population over the square root of the sample size 90, and that will yield the answer 7.38. And 7.38 will be your answer as to exactly the standard deviation for the sample. And what I then need to do is figure out how many times 7.38 goes into 120. It goes in about 16.26 times, and so 16.26 will be my answer. So that's a good example of a problem that you might get. So again, I give you a population mean and a population's standard deviation, and then I give you a goal, right? In a sample of 90 in this case, I'm hopeful to get a certain sample mean. And the question is how many standard deviations above the population mean is the sample mean that we're looking for. And when we say standard deviations there, we mean standard deviations of the sample, right? So sample standard deviations, not population standard deviations. The last thing, and I really want to hammer this home, because this is like a direct key in on a question you might get on a midterm from me. Let's say I have a sampling distribution, and it's approximately normal, right? And I have a value that is my mean or close to it. And let's say on either side, you know, they're only about 10 points off. I know, it's only about 10 points off. So it's like 50, 60, 70. and so on. And you're looking at it, and it doesn't say, right, about how far a standard deviation is, but it looks approximately normal. So you estimate from just seeing this graph that it's approximately 10, your standard deviation for this little distribution, right? What I want to be sure you understand is if we treat this as I know it, I'm trying to tell them the secret. So what the question might say is, given this visual, what do you think the standard deviation is of the population? And they gave you a graph of the sampling distribution for that population. So what you would do is you would take your estimation for the standard deviation for the sampling distribution of the population, which is 10, I know. And with that, given a sample size, let's say they say n equals 30. So this is a sampling distribution of a bunch of sample populations of 30. 10 would be your standard deviation for the sample populations. But then, if you want to know what the true population standard deviation estimate is, which is what they might be asking for, wink, wink, hint, hint, I know, we would say 10 is actually equal to what we're looking for, the true standard deviation, over the square root of 30. Like so. And we would just multiply the square root of 30 by 10. And that yields a value of about 54.8. So be aware of when you're being asked for one standard deviation or another, and be able to jump between finding the population standard deviation, right, the true, and the standard deviation of a sampling distribution or a particular sample. I am so proud of you. My final piece of advice is this, from both of us here. Review along and along, take your time, go through the old video notes, practice as many problems as you can. Remember that this is a critical thinking exam, an opportunity for you to show off all the tools that we've learned together, and for you to show me all the brilliant things that you can do with those tools. Have fun, practice, 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 practice. Do not get stuck. Be aware that no matter what happens, you can reach out to me, and I will have you, and Miles will have you covered. Miles, show them how we stand. Can you show them how we stand? Oh, look at us stand. What a legend you are. Good job, buddy. Go through those, go through your review guide, ask me questions constantly. We are here for you. This is who's answering all your questions. And prepare for this like it is actually the AP exam, because this is the first time all year that you've had a truly cumulative assessment of any kind. From all of us here, we want to say thank you, and you are privileged to teach. And Miles adores you, and I adore you, and if you need anything at all, let me know. But this has been the midterm review. Please note that all the things I've done are basically go over vaguely all the big concepts you should spend the most time on. There are other things here and there, be aware of them, but make sure you know how to do all those things that I've in vague terms gone over here. If you have questions about any of those, ask away. Go looking through your notes and your old materials for questions that mirror them, and please know that we are here for you. This is Mr. Mays and Miles signing off. Say bye, Miles. Do you say bye?